a hidden dark universe. When we look at galaxies, they spin way faster than they should. Could dark matter be the missing puzzle piece to understanding the cosmos? Or is it something even stranger? Hey everyone, welcome to Cosmos Realm. I'm Ruhi, and today we're going on an adventure into one of the biggest mysteries of the universe, dark matter. Now I know what you might be thinking. Dark matter? That sounds like something out of a sci-fi movie. But here's the mind-blowing part. It's real. Even though we can't see it, touch it, or detect it directly, scientists are convinced it's out there. In fact, dark matter makes up a huge part of our universe, about 27% of it. But what is it? How do we know it exists? And what if dark matter is hiding secrets that could change everything we know about physics? By the end of this episode, you'll have a deeper understanding of why dark matter is one of the biggest unsolved mysteries in physics, how scientists discovered it without ever seeing it, the groundbreaking experiments trying to detect it, and some of the wildest theories about what dark matter might actually be. So grab a seat, let your curiosity take over, and let's dive beyond the visible into the hidden side of the cosmos. Ready? Let's go! Alright, let's start with the basics. What exactly is dark matter? Well, here's the short answer. We don't really know, but here's what we do know. When we look at galaxies, they spin way faster than they should, based on the amount of visible matter, stars, planets, gas, and dust. According to the laws of physics, galaxies should be flying apart, but they're not. Something invisible must be holding them together. That something is what we call dark matter. Dark matter doesn't emit, reflect, or absorb light, which is why we can't see it with telescopes. But even though it's invisible, it still interacts through gravity, influencing galaxies, galaxy clusters, and even the entire structure of the universe. Imagine a huge cosmic spider web made of dark matter, shaping how galaxies form and move. It's like the invisible scaffolding of the universe. But how did we figure out dark matter exists if we can't see it? Let's travel back in time to when astronomers first noticed something strange in the cosmos. The curious case of missing mass. Our story begins in the 1930s with a brilliant Swiss astronomer named Fritz Zwicky. He was studying a galaxy cluster called the Coma cluster and noticed something odd. The galaxies in the cluster were moving way too fast. So fast that they should have been flung away into space. But they weren't. According to the laws of physics, there simply wasn't enough visible matter to produce the gravity needed to hold the cluster together. Something invisible had to be providing extra gravity. Zwicky called this mystery substance dark matter. At the time, most scientists ignored his idea, but decades later, in the 1970s, a scientist named Vera Rubin made a groundbreaking discovery. Rubin was studying how stars move inside galaxies. Normally, based on Newton's laws, stars at the edges of a galaxy should move slower than those near the center, just like planets in our solar system orbit the sun. But what she found shocked everyone. The stars at the edges of galaxies were moving just as fast as those near the center. That shouldn't be possible unless something invisible was adding extra gravity to keep everything moving together. Her discovery was the final proof that dark matter was real, even though we still didn't know what it was. But if we can't see dark matter, how do we study it? That's where modern science comes in. Even though dark matter is invisible, scientists aren't giving up. They've designed some of the most incredible experiments to detect it. Underground detectors. In the deep underground places, experiments like Xenon experiment in Italy or the Lux-Zemplin experiment in the US, massive tanks filled with liquid xenon are waiting for a dark matter particle to collide with an atom. If that happens, it should create a tiny flash of light, a sign that dark matter has been detected, searching the cosmos for clues. NASA's Fermi Gamma Ray Space Telescope is scanning space, looking for signals that might come from dark matter decaying or interacting with normal matter. But what exactly is dark matter? That's where things get really interesting. Scientists have proposed some mind-blowing ideas about what dark matter could be. Weakly interacting massive particles. Hypothetical particles that barely interact with normal matter but have mass, making them a strong candidate for dark matter. Axions, tiny, lightweight particles that could solve multiple mysteries in physics, including dark matter. Primordial black holes. Some scientists think dark matter isn't made of particles at all. It could be a bunch of tiny black holes left over from the Big Bang. A hidden dark universe. What if dark matter isn't just a bunch of particles, but an entire hidden universe with its own dark forces, dark planets, and even dark life? Crazy? Maybe. Will we finally solve the mystery? Right now, we're on the step of a scientific breakthrough. New experiments, advanced telescopes, and powerful supercomputers are all working together to finally uncover the truth about dark matter. So what do you think? Could dark matter be the missing puzzle piece to understanding the cosmos? Or is it something even stranger than we have ever imagined? Let me know your thoughts in the comments. And if you enjoyed this deep dive into the unseen universe, don't forget to subscribe to Cosmos Realm and hit that notification bell so you never miss an episode. Until next time, keep looking up.